Okay, so in week 3, we are going to kind of dive more into select statements. But this time we're going to learn a couple new things. We're going to reiterate on some of the stuff we learned last time, but we're going to add some more as well. So we're going to do some joins, which are really fun. So we're gonna learn how to do some joins. We're going to learn a couple new keywords that will help us do various things, and then we're also going to learn about aggregation. So we're actually just going to kind of dive right in here this week. And I'm going to try to show you a few examples, and then we'll go over the lab similar to what we did last time. So let me get this pulled up here. If my mouse can find the thing. There we go. Okay. Let's put you away. Put you away. All right, so what we're going to do is I'm just going to go into our Lab 3 folder. So I'm going to go to Home, Data, 225, Oracle Lab 3. And you know what? I could work right out of this one, and when we go over the lab, I will. But for now, I'm actually going to create a new text file right here, and I'm going to call it demo.sql. All right. And then let's open up a terminal. And again, if you want to use that shortcut, I'm going to say actions, open a terminal here. We'll actually just close that other terminal window. All right, so what we're going to do is let's log into SQL Plus first off. And we are going to start with a little keyword that's going to be really handy. And you'll come across this quite frequently. In fact, it's a very utilitarian function, and I use it frequently just to kind of like get a glimpse of how many records are in the table. So that's kind of where I want to start with. So if I go select count, not count, and then in parentheses, you can put an asterisk to count all the rows, and then you say from contact, let's say. So if I really quickly wanted to see how many rows are returned by a query, I can use that count keyword. So if I say select everything, select the count of everything from contact, I get 12 rows. And if I instead do select everything from contact, you'll notice that I get all the data, but I get 12 rows. And let's adjust my line size here. So we're going to say set line size to 100. There we go. That looks a little better. So we get 12 rows in all of our data versus if I run our select count, we just get the number of rows. And that is handy, especially if you already know what the data is and you just like kind of want to see how many records are in the table. You can do that. Or if you want to say how many specific, so like we can say select everything from contact where last name is equal to, and let's say, do we have Sweeney's? I think we have Sweeney's. So we can take and select the count of everyone whose last name is Sweeney, and then we get 3. So that's nice if you just want some basic numbers, and it's also really nice for utilitarian purposes. And so we'll talk about some more of that here in a minute when we get to aggregation, because we'll talk a little bit more about that. So that's one keyword is count. You can get a count of rows in a table. The other one that we're going to learn is distinct. So if I say select distinct, and let's just say everything from contact. Now this is a terrible example because I'm actually going to pull every row in the table. You know, I get my same 12 records. But if I change this, if I add some columns to this select list, so I'm just going to add last name to here. And what the distinct clause does is it says, okay, I only want one, like if I come across multiple values, I'm just going to return one of those. So in this case, I get 8. And so you'll notice like win, I only get 1 win because basically we're returning unique or distinct values or a combination of values in that result. So now what I'm going to do is I'm going to add, and like I said, this is not a great example because these are all very unique. Let's see if there's another table out here. So let's do credit card type and member type. Although unfortunately those are, yeah, let's just do credit card type and member type. So if we go select distinct credit card type and member type. From member, we get every unique combination of this. Right? So we get the unique combination. So you'll notice in this case, we only get 2 records, and that's because 1004, 1005, and it's the same thing. Oh, and then we get a 1003 and a 1007. And that's a little backwards, I guess, but you get the unique combinations, and those are really handy because when we start talking about joins here in a minute, you can often use select distinct to help you consolidate rows to get rid of unnecessary ones, and we'll talk about that here in a minute. And so now we're going to move into aggregation. And aggregation is a way that we sum things up, or we compress multiple rows of data down into fewer rows of data. We aggregate the data down into more of a summary. I guess a great example of this would be if we wanted to take, all of you guys' course scores and aggregate them into a GPA. We could write a select query to aggregate that data. So we're going to actually write a little aggregation here, and I'm going to take a look at our rental table and see if, well, let's try, we'll use count. So we have our count here. Let's see what we have for rental item.
Check the item table.
Item table? Okay.
Yeah.
There we go. Okay, so there's quite a few here in the item table, and we can aggregate a few things. So, you know what? We have this item rating, with these various PG, mature, teen. So we're going to aggregate this, and we're going to see how many of each type of rating we have is in our database. So to aggregate, we start off just like any other query. And what do we want to see? Well, we want to see the rating type. So real quick, let's see what that column's called. So let's describe item, and it is the item rating. So we're going to take our item rating, because that's what we want to show. And then we want to see the count of each one of those. So I'm just going to go like that to show the count. And we can even give this a name. So I'm going to say as item count, something simple. And then we're going to say from item. Now I'm going to leave it like this, and this is going to throw an error now because it says not a single group function, and that kind of sounds weird. But essentially what it's saying is, hey, you're trying to aggregate, but I don't know how to do that. Like, what do you want me to count by? And we know that we want to take, and we're organizing this by item rating. So that's what we're going to group by, because essentially what we're going to do is we want to take, Star Wars 1, Star Wars 2, and Hunt for the Red October, and we want to aggregate those all down so that we only see PG and 1, 2, 3, 4, for example. So what we have to do, anytime there's an aggregate function, you have to add a group by clause. And the group by clause is pretty easy. And this is general rule of thumb. Take whatever you have above the aggregate function and put it in the group by clause. So in this case, I'm just going to put item rating. So we're going to select the item rating because we want to show PG or PG-13 or whatever. And then we're going to get the count of each one of those. And we're going to determine how many counts there are based on the item rating. So let's give this a run here. And this time we should get our counts. So we have 1 PG-13 movie, 4 rated for everyone, which are probably video games, 7 PG, 1 not rated, 3 teen, 1 mature, and 4 rated G. So you can see how we can aggregate the data, and this is kind of where a lot of the value comes out of writing select statements. Another example. So the model of our database is that we have a member table, right? And then we have this contact table. And so just like if you think about old video store or even Netflix, right? Netflix is a great example. You can have one Netflix account and have multiple profiles under that account. Now, in our case, we have address and telephone numbers for each account. Netflix doesn't really do that, but imagine a contact being like a Netflix profile and member being the actual like paying account. So, like on mine, I have an account in for me and my wife. We have one for our daughters, whatever. But I'm the only one who's paying. So our membership is what handles our credit card number and our account number. And then the contacts are all belonging to member. So in this case, we have a member ID here that ties us to a member. So what we're going to do here real quick is we are going to get a count of contacts per each member. So basically we want to say, okay, how many people are there for each membership? Okay, so that's what we're going to kind of do right now. But there is one important thing that we need to do in order to achieve this, and that's we have to do a join. And joins are really cool. Joins are, and I think I put this in the announcement, joins are what make databases so powerful. In the reading, you might have come across a relational database management system. And it is the joins that kind of effectively use the relationship portion of this. And I can't remember if I put it in the announcement. I thought about it, but I didn't know if it sounded too harsh. But this is, after you see this, you're probably not ever going to want to use a spreadsheet ever again. So, we have our member table. So let's select everything from member. And we have a contact table. And if we look at this, you can see that this one has, some credit card information and all that kind of stuff. And this one has first, last name, kind of like what we talked about with the profiles. Now, if you were going to try to manage this in like an Excel spreadsheet or Google Sheets or what, pick your poison, you would have to have, some weird, crazy table stuff going on. What's nice about this is we can tie multiple people to one record. So in this case, you'll notice member ID 1001 ties to one record here. Now, what we want to do is we want to pull this information together so that we can say, okay, Randy Wynn is account number B293714445. Or Randy Wynn has credit card number, 111222, so on and so forth. And we do that with this member ID. Now, these two things here, so you'll notice the member ID here and member ID is here. You'll notice that that's the only data that duplicates across these two tables. And that is because we have to have some way to tie them together, right? And that is, we'll talk more about that in the future, but normalizing a database is about reducing data redundancy. And by data redundancy, I mean, we don't want to have to change. Imagine if we had credit card number inside of the contact table. And let's say that, where's a Sweeney? Let's say Megan Sweeney comes in and says, oh, I need to change the credit card number on my account. Well, now we have to make sure that we change that credit card number not only once, but 3 times. So you can obviously see that there would be some issues there because the least amount of times you store the data A, you use less storage on disk, and B, um, it saves you in data problems in the future because, you know, you can imagine office staff trying to keep track of multiple points of location where data is stored. It just adds more cause of probability of problems, I guess I should say. So these two columns that are shared, so in this table, it's called the primary key. And you can see that every table, for the most part, every table we're going to be dealing with has a primary key. And that primary key is unique to every row. Every table's got to have one. Just like in your spreadsheet software, you know, there's like the 1, 2, 3, you know, the rows that the number that identifies the row that you can't change. Well, that's what the primary key does for our table. It uniquely identifies a row. There can't be two 1001 primary key in the member table. You know, there can only be one. And same thing with contact ID. There can only be one of them. So in the member table, member ID is the primary key, right? And I'm going over this a few times because that concept is massive. Primary key is something you'll hear numerous times, probably every week from here on out. So member ID is the primary key of the member table, just like contact ID is the primary key of the contact table. Now we have this member ID here in the contact table, and we know that it's not the primary key because contact ID is. And so this one, and this is kind of how I like to remember it, because I'm like, okay, member ID doesn't really belong in this table, right? Because this is about the contacts, but we need it to tie back to a member. So member ID in the contact table is called the foreign key because it's foreign. It points to somewhere else, right? That's how I like to remember it. You know, it's like the foreign, you know, the one thing that's different that points you to somewhere else. And it is that combination that we use in our join. So right now we're going to write this join, and there's lots of different types of joins, which we'll go over, but the most popular one is our inner join. And I kind of wanted to show you this, and I posted this in Teams, but inner join is kind of the bread and butter SQL join. And it'll make sense here in a minute, but I always use these Venn diagrams. In fact, even when I took my certification exam, just to double check myself, I'd always draw this little Venn diagram so I could visualize it. So in this case, table A is going to be member, and table B is going to be contact. And what we're going to do is we're going to put these two tables side by side, just like this. We're going to put these two tables side by side and kind of try to glue the rows together. And we're going to do that with an inner join. And what the inner join means is that we're only going to find the records that have matches. Now, in our database, hopefully everyone matches, right? There's no contact that doesn't have a member. In our database, that would be impossible, but in other situations, it won't be. And so that's what we're going to do. We're going to take that inner join, and we are going to find everybody who has, we're going to find every member who has contacts. Now, there could be a member who doesn't have any contacts technically, but not in our database. And we're going to do that based on the primary and foreign key values. Because when we do this, we have to have some way to tell the computer, you know, what record goes from A to B or from B to A. So let's do this. So we're going to say select, and I usually, when I'm writing these, I usually just start by selecting everything. So I'm going to select everything from member, and then I'm going to say inner join contact. And if I just do this, you know, I didn't specify where I'm going to match stuff on, and you'll notice that it says I'm missing a keyword. But if I add this keyword, I'm going to say I want to match on. And when we say on, it's almost like saying where, right? That's kind of like the way I want to say it. So, well, how do I know how to match these? How do I tell the computer to match these? Well, we can look at this and kind of say it ourselves. Well, I want to match it where the member ID, you know, because if we were just looking at this, if I wanted to say, okay, what account does Matthew Sweeney have? Okay, Matthew Sweeney has member ID 1003. And so I look for member ID 1003, and oh, he has account number right there. Well, so we pretty much did it, you know, and everyone can do this. If you said, oh, you know, find out what account number Matthew Sweeney goes to, you could do that. Well, now we just have to tell the computer how, and it's just almost the same way that we did it with our own logic. So we're going to say, okay, 1003, well, that's member ID. So we're going to say where member ID is equal to member ID, right? So let's do that. I'm going to say, now, one thing we have to do different is we have to specify which table things come from now. So I'm going to say member dot member ID is equal to contact dot contact ID. Right? So basically we're going to pull all those records together where the member IDs match, and that didn't work for whatever reason because I have a semicolon.
Yeah, it's member ID. It's contact.member
Oh yeah,
ID.
yep, correct. Yep. Sorry, sometimes I get talking and type what I'm thinking. Okay. And there we go. And so we get our 12 rows selected, which is good because we're joining it all, and that's a mess. So let's you know, that's a mess. So we want to filter this down. So let's say we just want to see the name, or let's get the member ID. So let's get member.member ID. And let's get member.account number. And then let's get contact.last name and contact.first name. There we go. That looks a little better. And so now we can see the member ID, the account number, and then the names. And we get our 12 rows. And now you can see that we've now taken, you know, stuff from member, and we've also tied it to contact. And right now we're using an inner join on that. Now in this case, I kind of want to break down and show you what's happening when we do this join even more because it's important. So real quick, I'm going to show you a full join. So if I do this same, let's just take and copy this. I'm going to take this same join and I'm just going to edit it a little bit, because instead of doing an inner join, we're going to do a full join. And we're going to look at the differences of this. Now a full join, and there's another really great, a full join is basically table A times table B. It's also called the Cartesian product, which means we get every possible combination. So let's take and put this in here. Oh, and I'm missing a keyword. Oh, not a full join. Sorry. Again, I'm reading what I'm seeing on the scene. A cross join. A cross join is the Cartesian product, which means we get every possible combination. It's like saying take member and multiply it by contact. So what we're going to get is 96 rows. And you'll notice that for every member, now there is every contact. So if we were to sort this, so let's go order by contact.last name. I guess, yeah, last name. And contact.first name. So let's sort it so we can kind of see what's going on here. You'll notice that every person has a record for every member, which obviously is not what we want. So you'll actually see every person's name, however many times that there was a member, however many rows were in the member table. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So we have 9 records for every person because we effectively multiplied it. We got every possible combination, which can be really handy sometimes, which we'll see lots of demonstrations in the future. But essentially what the computer does, for an inner join is it actually gets a full join. And what it does is it takes all the combinations and then it filters them. So if we can do this cross join just like this, but let's add a where clause. Let's say where, and we did member.member ID is equal to contact.
Brother Cook,
Yes. Did someone have a question? Okay, well, if it comes back up, feel free to ask. But we added that where clause to the cross join, and that's essentially what we're doing with that inner join. It's just a shortcut, and in fact, it actually has better performance. But we end up with the same results as what we did with the inner join by using the where clause. All right, so there is kind of the inner join that we just went over. And so let's talk about some of the other ones. And for this, I'm actually going to kind of jump over to the labs because they've got some pretty good examples that we'll talk about. So step 1 says write a query that returns the count of the number of rows of the member table. That should be super easy. I'm not going to do it for the member table, but I will real quickly do it for another table. Let's say we want to see how many movies we have. Select the count from item. We have 21 movies, or at least 21 records. So there's how you do that one, just with a different table. All right, step 2 says write a query that returns the last name column values and the results of count function with an assigned column alias of total names, and order the return by the ascending number of last name occurrences. You will need a group by clause because one column is aggregated and the other column is not. You group the non-aggregated last name column in order by the column alias for the count function. So let's go over that one real quick. So I'm actually going to switch over here to our apply Oracle Lab 3.SQL. All right. So step 1, we kind of did an example for, but for step 2, we are basically getting every last name, counting them, and then we're going to order them in ascending order. So we want to start with the least number of people with last name and go upward. So we're going to say select and then last name from contact up. And you can do this. So order, and we'll skip the order by. Whenever I write queries, a lot of the times I like to start, and this is an extreme case, but I like to build them component by component. So there's our foundation, right? We have our last name. Well, now let's add the count. So we say count of everything, and we want to call that total names. And we know because we added that aggregate function, we have to add a group by, and we're going to group it by last name because that's what we want it ordered by or group by, but it's also because what's the only other thing in the select list. And so there we get our total names. So now all we have to do is add the order by. And order by always goes last. We say group by last name, and then we order by total names. Let's see if this works. And there we go. So now we have the last names and the total number of people with that last name. Now, this is actually a query that I run sometimes against the database at work, just because we often have little bets to see who knows, the popularity, which last name is the most popular in the area, and it's always fun. So we do this actually quite frequently in the office, just for fun. All right, so there's step 2. And step 3 says, write a query that returns the item rating column values and the results of the count function assigned with the column alias of total count. And so we actually did that, but the only difference is this one says you filter the results with the where clause. And it says it should filter rows by the item rating values that equal G, PG, or NR. And then sort the results by the ascending order of item rating values. So we actually already did this one. The only difference is we didn't add that where clause. Now, just for review, if I wanted to select the number of if I wanted to select the rows of a table who had that that value, I would say select everything from item, where, let me pull this up so we can see a little better. And I would say where item rating in, and then I could give it a list. And in this case, we would have like a G, a PG, and remember case matters. So you want to make sure the case is right and not rated. So if I were to do this, then we can kind of build a list. And as long as it's in that list, we're going to pull that. So basically, you just have to take our previous example and this one and tie them together. And that one is right here. So you could take those two examples, tie them together, and that will give you step 3. All right, and then step 4, we're going to write a query that returns the last name column value from the contact table, the account number and credit card column values from the member table, and the results of the count function with an assigned alias of total count. So again, we've done something very similar to this. And it says you join the member and contact tables based on the values matching between the member ID column held by both tables. So pretty much exactly like we did. And then it says you must group all non-aggregated columns and sort the result set in descending order based on the results of the count function. So the only thing that we didn't do different on this, that we did, that this one's going to be different, is that A, it's in descending order, and it's actually going to have a couple additional columns. And it says you must also filter the aggregated results with a having clause, and the having clause should check for the count row of results greater than 1. So let's actually run through that one real quick. So we're on step 4. So we are up, and I went right above where that was supposed to be. That was for step 2. There we go. Okay, so step 4, what we're going to do is we want to get people, their account and credit card numbers, and the count of all those. So let's take a look here. So again, like I said, I like to build these in small little chunks because, and I'll show you why here in a minute. If I put contact dot first name and then member dot member ID, I have to build out the whole join, right? And sometimes that might be too much, especially when you're learning. And even for me, when I get in these massive queries, I build it little chunk at a time. So what I always do is I start with I go column by column. So I say, you know, contact, and what do we want? We want the last name, not first name. So let's start and change this to last name. So we're getting the last name from contact, right? And you can even run these in between. That's why I like to build them piece by piece. So we got that. We got our last name. Now, while we're doing this, I'm going to show you one little shortcut, and this is called a table alias. So instead of typing contact and member every time, we can kind of give this a nickname. So I'm going to say from contact C. And so then instead of having to write contact dot last name, I can, in my from clause, put contact space the name of my alias, and I could run this, and we'll get the same results. So that's what I like to do a lot. It doesn't have to be one letter. You know, you could put contact CT, as long as it's, you know, the same everywhere. You could do whatever. It does have to be unique though for that query. So I'm going to call it contact C. Now what I'm going to do is I'm going to add my member, inner join, and we're going to call this member M. And we're going to join on c dot member ID is equal to m dot member ID. Right? Now, I could add, let's add our other column here. And let's add our account number. Not forget our semicolon. Oh, and I'm missing something. I missed the join clause, the join word. Somewhat important. And there we go. So now we have the last name and the account number. And like I said, I like to build this piece at a time and run it every time, because that way, instead of dealing with 5 errors and being totally lost, you know exactly that, well, it worked the last step, so something I did in the most recent change is what broke it. So that's why I like to build it piece by piece, and you can watch the data grow as you do it. So that way, if you ever end up with a million rows, you can know exactly what step broke it. Okay, so we got the last name, the account number. We would also add the credit card number. We could even add this. I mean, we're pretty sure it's going to work, but let's run it. There's their credit card number. And then the last step is we want to add the aggregate. So how many people have that last name and have that account number? So then we would say the count of, and what did they want? The count of every, oh, yeah. So yeah, we'll just get the count of everything as the total count. Right? So now if we were, oh, go ahead.
Got a quick question. When we're looking at the joins, in this case, an inner join and a left join, when we're saying it's having more than one, does that matter? Are you going to count on the joins?
Nope. As long as you get the desired output, it doesn't matter too much.
Okay.
Yep. But that brings up a good point. If we wanted to find all the memberships, even if they didn't have a contact, we would have to use something else. And in fact, we would have to kind of swap this around, because right now we go from contact and join member to contact, which means that if we did a left join, we would get all the contacts regardless of whether they had a membership or not, which, like I said, in our database, it's actually not possible to have a contact without a member. But we could just take and put this member M and interjoin this to contact C like this, and it'll be the exact same. But the only difference is now is if we did a left join here, we would get everything from table A regardless of whether or not it has a match. So let's say that there's a membership that doesn't have a contact. If we did an inner join, we're not going to see that row. If we use a left join, we'll see that row. So, you have to be really conscious about how your data works when you're doing these, because, for the most part with these, everything's pretty solid. But, in other situations, there might be times where it is possible for someone not to have a rental per se. Like if we were going to do this with a rental, we could do the same thing. In fact, after that, we'll do a real quick example of that. So we get our count and let's aggregate it. We're going to leave that as a left join for right now. We're going to aggregate it with our group by. Now, because this has multiple columns in front of it, we actually have to kind of take and group by all these things. And so a lot of times what I do is I just take the select list and go like that. All right, so let's do this. And we get our 8 rows with the total count. Now, if we look at the instructions, it asks for one additional thing, and it says you must also filter the aggregated results with a having clause, and the having clause should check for the count of row results greater than 1. So in this case, what it's saying is, like, all these people that only have one person in their membership, we want to exclude those. So essentially what we're doing is we're saying, hey, pretend that you're the database admin or the data engineer, whatever you want to call it, and you work for Netflix, and the the boss comes to you and he says, hey, we're trying to see if we should add another plan to our offerings. And we want to see how many people have multiple profiles on their accounts. And we want to know who they are so we can pull their demographics or whatever. So you say, sure. But again, like we said, all these people with one profile, that's all the singletons, and we want to exclude those. So what we need to do is we need to add one little piece to this, and it comes after the group by, and we say having, and this is where we can kind of say what we want, and we want to say having a count that is greater than 1. And I don't believe we can do it this way. This is one of those things that change from database to database. So I'm going to change from having a total count greater than 1. I believe we can do that. Total count. Oh, nope. That's the one where we can't. So we're going to say having a count that is greater than 1. And there we go. So now we're left with all the ones that had a count that's greater than 1. So Win, Sweeney, and Risquel. So then you can give this report to your boss and move on with life. And then furthermore, to finish off this step, you'd want to order it, I believe. Does it say to order it? Actually, you may not have to order that one. So if it says to order, oh, no, you do need to sort the result set in descending order. So you would add the order by clause to sort descending. Now, remember, if you want to sort descending, you have to put the DESC keyword afterwards. All right, and so like we just talked about, we're actually going to test to see what happens if you don't have a matching record when you do a join. And I think that there's an example of this in between our member and rental table. So real quick, let's take a look at rental with our describe command. And you'll notice here that we have rental ID and then this customer ID. And this customer ID, this is one of those cases where the names don't actually match, right? And so what we have to do is we have to look at the data and more importantly, look at what created the data. And so just to show you, I'm actually going to go and always the definitive source is to actually go to the table creation statement. And we have all those. They're in this lib1 folder under create, and we're talking about the rental table. So I'm going to click on rental.sql, and I'm going to take a look in here, and we'll talk more about this, but just to show you, if I look at this rental table, I can see that our customer ID references contact ID. So now I know exactly where that ties to. And there's a way you can query that out of the database, but we'll talk about that in the future. So we know that customer ID references contact. So if I wanted to get a list of all the rentals with their contact, I would say, let's select C dot first name and C dot last name from contact C. Let's build this one step at a time here. So this is going to give us our contacts. Now we want to add some rental information to that. So we're going to do an inner join right now. Now you'll notice we got 12 rows of people. So I'm going to say inner join rental R on C dot contact ID, right, is equal to R dot customer ID. Because contact ID is the primary key of the contact table, and customer ID is the foreign key of the rental table. Now, I like this example because those column names don't have to match. Your data might not, your columns may not have the exact same name between the two, but it is the data that was defined to match on. So this is a good example for that as well. So we're going to take this and we are going to run it. And now you'll notice that we get fewer rows returned. we instead of getting 12, we get 1, 2, 3, 4, 5. Now let's add our rental ID here so we can just see some rental stuff. So now we have our rental ID. Right, so there's our various rental IDs for our different people that have rented a movie. Now, you'll notice that we have people missing. Now, let's say that we wanted to see everybody, regardless of whether or not they had a movie rental. You know, we want to see how many movies people have rented or whatever. So instead of an inner join, we would change this to a left join. And just by changing that one word, we are going to get very different results here. So now you'll notice that we get everybody, but you'll notice that many do not have a rental ID value. And that's because we did a left join. So it just paired them up with empty data. So now what we can do is let's actually pull a count of how many rentals a last name had. So let's just take our last name. We'll make it the first one here. So we're going to take our last name. And then we want to get a count of our rental ID. And we'll call it rental count. Now, because we added that count, we have to add a group by clause because we're aggregating, and we want to group by c.last name. And now we can see how many rentals each last name has. So we can see that the Sweeneys had 2 rentals. Visquel had 2 rentals. Now we just did this by last name. So let's say we really wanted to solidify this, because let's say we had 2 accounts that had, let's say your boss comes and he says, look, I want to know the account number, the last name, and the number of rentals that they've had. So you say, okay, no problem. But if we look at this, well, we've got contact and rentals, but we need to add member to this, right? And we need to add it up here. So this is what we're going to do. We're going to say inner join contact C. We're going to say from member M. But then we need to add an on clause because we're adding another join here. So we're going to say M dot member ID is equal to C contact dot member ID. So whenever we're doing multiple joins, a join is always isolated from itself. So we could actually take, and let's just separate this out a little bit. I'm just going to take and comment this out. We're going to just adjust some things here. We're going to get the account number from member, and we're just going to run this little piece of it here. So basically we're going to get the last name and the account number. And it looks like I forgot something. From member M, and it doesn't like this. So let's just take it, paste this down here for now. Oh, it was a comma right there. Okay, so we're going to just get our account number and last name like we've done a lot of times. So now we have the account number and whichever last name that belongs to. Now you'll notice that we have a few of them because our last name has multiple people. You know, we're not pulling the first name. So here's another great opportunity to use one of those new things we did. Let's add distinct to this. We just want to know the distinct account numbers and last names. Okay, so now we have, you know, essentially the same last names and the account numbers. So now that we added distinct there, we can see that. So now let's go ahead and let's add our rental stuff. So basically what we're doing is we're taking the exact data that we had up here, and we are now going to add another table to that. So anytime you do a join, after that join, so after this right here, this is almost like its own table now. So whenever you do a join, think of it, oh, that is now joined. It can't be undone. It's its own thing. So now when we do our left join, we're going to take and join all of this Now, we're not just taking contact to rental. We're taking all of this to rental. Okay, so we could do a join from member to rental if we wanted to. Now, we don't have a match of data there, but it's possible. So let's take and let's join that up, and let's add our count here. So now we want to get the count of all of the rentals as the rental count, and we want to group that by the last name, or now we need to add some. So we're going to say the account number and the last name. And so now we're left with the account number, the last name, and how many rental they've had. So then, like, this kind of report would tell you, okay, the account that is doing the most rentals and what's their last name, or which accounts are not, having any rentals. If we were a moral company, maybe we'd call them and say, hey, you haven't used your account any. Do you want us to cancel your membership? I mean, I don't think any company would ever do that, but, theoretically it's possible. Or just send them a reminder, say, hey, you know what? You haven't been used this. Maybe you should check it out. So anyways, there's a good example of a multiple join situation. And with the rental, and again, let's change this left join to an inner join, right? And we're going to watch how these results change. Essentially, all these ones with 0 are going to disappear. So you want to be careful with that inner join because it will exclude records that don't have a match. And the reason that it excluded them is because not every contact has had a rental. So it excludes them. Does that make sense to everybody? The difference between that inner join and the left join?
Yes.
Okay, perfect. Perfect. Okay. So let's move on. There's some great ammunition for step 4. All right, so let's take a look at step 5. So step 5 wants you to write a query that returns a unique. And whenever you see unique in a select statement, if you want a unique set of rows, that means distinct. So you're going to write a select statement with a distinct keyword that returns unique last name, city, and state, province, column values from the contact and address tables. You will join the contact and address tables based on the contact ID column held by both tables, and the distinct operator returns a unique set. And then it says you must sort the rows based on the ascending value of last name column. So I'm not going to do this one for you because we've seen plenty of examples. So this is one that you guys can do, I'm positive. Okay, step 6 is another distinct one because it says unique, and we're going to get the last name, area code, and telephone number. And this one's going to be a little different because we are going to format the area code and telephone number columns into the concatenated string. So basically, instead of getting 4231234 in one column and then the area code in another one, we want it all in the same. So this one's nice and easy, actually. I think I actually showed you an example of this last time when I showed you how to concatenate a full name. We're going to do that again just with the telephones. So if I say select everything from telephone, we can see the area code and the telephone numbers. So if I wanted to get the area code and the telephone number combined, I would say select. Let's do it over here so we have it in case we need it. Select, and we could use the concat keyword, but that's not very handy. So we would select our area code, and we would pipe that with telephone number from telephone. And we could give this a keyword as, let's just call phone. So we use those pipes to concatenate stuff. Now you'll notice that we don't have a space there. That's kind of just threw it all together, and it wants it in parentheses. So we would have to do a little work here, but we could add some string literals here to say, oh, we want to concatenate one of those, and we want our area code, then we want a closing one with a space, and then a pipe. So, we can format these strings how we want, and then we get our phone number all pretty. All right, so we do that. You'll use the distinct operator and sort the rows. So I'll give you that example and let you guys handle the rest on that one as well. For step 7, we're going to write a query that returns the common lookup ID, common lookup context, common lookup type, and common lookup meaning from the common lookup table where common values equal a set of values. So this is going to be another one of those in operators, and this one actually doesn't have any joins. So this one's just kind of be a throwback to last week. So you'll just have to use your where clause and use your in statement. Step 8 says you're going to write a query that returns the item title, item rating, column values from the item table after joining the item and rental item tables matched on the item ID column values. So essentially what this one's going to do is, and it actually says you can use solution to step number 7 as a starting point for this, which is great. Basically what we're going to do with this one is we're going to see the item rating of various movies from the rental item table. So we can see what movies were rented and the rating of those. Now, one thing I want to go over real quick is this little table called common lookup. So if we take a look at what's in common lookup, you'll notice that it's kind of just, for lack of a better word, a hodgepodge. And that's why it's called a common lookup. And this is actually something that is used quite frequently to store common values. So like, let's say that you have, we've all used that web form with the drop down. We could have a common lookup value of, home and work for whatever, telephone, address, that sort of thing. We have different types of credit cards. So we have Discover card, MasterCard, that sort of thing. Or individual or, group. We have individual and group, and one's an individual membership, one's a group membership. So, this is kind of a place where we store all these common values. Now, the reason why they do this is because let's say you wanted to know every membership that was a group account. Now, we wrote one of these to see how many account numbers had multiple people tied to them, right? And in fact, there's a homework, one of the lab assignments for that has you identify how many people are tied to each account. And so you could use that to find group accounts. Well, we actually already have this. So like if I take a look at member, we have this group, this member type, and we can actually use this member type to identify whether it's a group or not. Same thing with credit card type. And these, so like if we look at member type 1004, this points to common lookup. So if we look at 1004 here on common lookup ID, you'll notice that, oh, this is a group account. So it stores common values, similar with credit card. 1005, well, we know that these people are using Discover card. Oh, and there's Visa as well. Visa's 1007. So let's actually write one. Let's get, this will be another little bit bigger query, but let's get all the members. Let's get the account number, and let's get the member type, so whether they're a group or an individual, and let's get the credit card type. It just, I guess, I always like to throw little situations on here because I think it helps us visualize and work through with our brain. Because a lot of times if you say, oh, just get this random data, it doesn't make any sense. But if I say, oh, I want my goal, the boss comes to you and he says, hey, does it so happen that there's more like group accounts using Discover Card? Like, does Discover Card like give you points to buy diapers with, or you know, is Discover Card better for families, and is Visa Card better for you know, single people because they give you fly miles? You know, something like that. You know, because that's essentially that's where the power of data comes from, right? You know, as a data analyst, that's pretty much what I do. And so that's what we're going to do. We're going to actually pull that data. So we are going to get, like I said, we're going to get the account number from member. So we're going to say m dot account number from member M. Okay, simple enough. And like I said, I do this, and you'll see me do less of this. I'm doing it right now to hopefully help those of you who want to, that are starting from nothing and want to build that confidence. This is a great way to go. Build your queries one step at a time. So we got our account number, right? That's a great starting point. Well, now what we want to see is whether or not they're a group account or an individual account. So just for the sake of viewing the data, I'm going to add member type, right? And we can actually just run this again. Now, when we run this, we can see member type, but we want this to be pretty so it's easy for our brain just to look at and kind of interpret. So we want to actually pull the right value. And so to do that, we need to connect the data to common lookup. So in this case, we're going to use inner join because we know all of them are going to have a match, right? It's impossible to have an account without having the member type. So we're going to join this with common lookup. And I'm going to call it CL. And we're joining. Now this is where we kind of get to choose where we want to join. And we want to go from member type, right? This is the only time we're not going to go to like, you know, we're not using member ID here. Member type is the value that points to this. Just like if we were going to look, you know, to see, okay, account number 71445 has a 1004 type, and that is a group, you know, so we're going from member type to common lookup ID. So we're going to go m dot member type is equal to CL dot common lookup ID. And once we do that, we can add our CL dot whatever. You know, if we put a common lookup ID here, we'd get two 1004s. And for the sake of, oh, go ahead.
It should be common lookup meaning if you want it.
Yep. Yeah, and a lot of times when I'm troubleshooting, I actually put the IDs just for the peace of mind to know that they match up. So because this way we'll be able to look across the board and say, okay, member type 1004, common lookup ID 1004, and then see the meaning. So let's go ahead and run this. And so now we can see the account number, the member type, and the common lookup ID. Now on our where clause, we match these. So these should all match, but just to kind of demonstrate, I put them there. And then our meaning. So now we can see that that's an individual membership. And then down here, we can see our group memberships. So now that we have that all matched up, we've checked it, I'm going to go ahead and take those out. Now what we want to do is we want to tie this to the credit card, right? Now this is where things get really interesting. And one of the main reasons I wanted to show this example, because if we add, now we already pulled common lookup meaning, and if we scroll up here, well, common lookup meaning, that's where we want to get our Visa card and our Discover card, our MasterCard. So we're kind of at a dilemma because, well, we're already joined up to common lookup. So what we're going to do is we're actually going to join again to common lookup. And what this does is it actually creates two copies of the common lookup table in memory. And we're going to just give this one a different name. So we're going to call this one CL2, right? And then we can say on, and in this case, instead of saying member type, we're going to say credit card type is equal to CL2 dot common lookup ID. Because essentially what we did is we made this table, right? Just like we had here. And now we're going to take that and we're going to join that to common lookup again. Just another copy, because we didn't change common lookup. It's still there. So we're just going to grab another copy. so we can add some more data on the side. And in this case, we're going to tie this version of common lookup to the credit card type. And let's grab CL.CL2, and you'll notice that we're going to even get the same column right here. So common lookup meaning and CL2.common lookup meaning, but they're going to be different because they come from two different instances of the table. So let's go ahead and put this in here. And now all of a sudden we can see that the account number, if they're individual or group, and the credit card type. And, you know, based on this, there's extremely, I mean, our sample size isn't large enough, but, you know, it would be safe to say that, well, according to our data, you know, groups use Discover Card and individuals use Visa. So, you know, that's what, you know, this obviously wouldn't work very good because we only got 8 rows, but, you know, if you're Netflix, the data would be pretty interesting to see. You know, what kind of credit cards different people use. So anyways, there's a fun example that shows you a couple different. We did a 3 join before. This one does a 3 join, but this one does it with 2 copies of the same table. Does anyone have any major concerns about that? I don't think you'll see this in the lab this week, but it came up naturally, so we went with it. Okay, another question. Is there anyone totally and utterly confused? And don't be afraid. If you're totally and utterly confused, we need to know so we can cover what or try to help.
I'm not completely confused, but there are things that are missing, but that's just me with the lack of database experience.
That's completely fine. So do you know, like, where do things get fuzzy for you?
Last week in the lab for, what was it, 8 and 9, I couldn't get those out, and I tried everything I could, and then I sought some help from a database administrator friend of mine, and even with his help, I couldn't get those. So going through and looking at what you're doing here with the end statements, that's helping some, but going back to the joins, I saw the graphic you had up earlier. That's a little confusing to me, but that's because I just don't understand it right now.
Gotcha. Okay, well, maybe it will help me talking about it some more. Maybe it won't, but we're going to give it a shot here for a minute. So, like, just, I guess, to go a little slower, what I'll do is let's take one of my favorites is contact and telephone. So if we describe contact, then we describe telephone, these are kind of going to be our A and B, contact being A and telephone being B. So when we join these 2 tables, I like to think about putting the rows side by side, right? We're not extending a list. We're actually going to take 2 rows and glue them together. We're matching data up. And so that's kind of what we're doing here is we're going to take A and we're going to put B right next to it and try to match some rows. And depending on what type of join we use is going to determine which data comes out of the result of those. So for example, if we were to take A and B and put them together and, you know, match them, and we only wanted the ones with matches. So imagine you have all your contacts here and all your telephones here. Basically what we're saying is, oh, which contacts have telephone numbers? So that we get what's in the middle. Versus if we do a left join, we get all the contacts, whether or not they have a telephone number or not. So that's kind of what that does. And it gives you a nice little template here. So we're actually going to take this template and we're going to put it right in here. So we're going to say select, and let's just get everything from now. And we're going to get everything from contact, C, I'm going to call it C, and we're going to interjoin that with telephone, T. And just like our little template says, we have to give it a way to match. So we're going to match on some data. Now, one of the biggest like aha moments for me, I actually remember when it happened. I was sitting in the lab of the Smith building at BYU, Idaho, when this made sense to me. How do we know what to match on? That's probably the biggest thing, because most people know, well, oh, I want to combine contact with telephone. But how do we know when we need to match? Well, 9 times out of 10 in our database, and I think it's actually pretty close to that stat, the column names will be exactly the same. But just know that we kind of have to connect the data where it connects. So if we look at contact, you'll notice we have contact ID, member ID, and so on and so forth. And in telephone, we have telephone ID and contact ID. Well, we're looking for the common denominator. So in this case, we want to know which contact ID the telephone goes with. So the common denominator between these two tables is contact ID. Now this is, like I said, 9 times out of 10, it's going to be this simple. And you can look for the common name. So we're going to say on c.contact ID is equal to t.contact ID. Right, so let's take a look at our Venn diagram again. So we match that because we got table A, the primary key is equal to telephone dot the foreign key, but they both happen to be contact ID. And what we're going to do is we're going to return everybody who has a telephone number. And not only are we going to return everybody who has a telephone number, but we're going to actually return all their data. So let's give that a run. Oh, and what's going on here? Okay, there we go. Sorry. Not quite sure what happened there, but it froze up. So if we run this, we're going to get everybody and all their information with their telephone numbers. So now what I'm going to do is I'm just going to clean this up a little bit by choosing what we want to actually select. And I'm going to get the C dot last name, C dot first name, and then T dot telephone number. So basically we're taking data from two tables and we're matching it up to get their telephone number. Does that help at all?
Yes, thank you.
Yep, no problem. And you know, a great way to visualize this is actually if you were to make a spreadsheet, right, with both sets of this data. So basically, you know, take the contacts and put those in one spreadsheet, and then take telephone and put those in another spreadsheet. And then try to use Excel to match that data together. It's nearly impossible. In fact, one of the examples I always use is emails, you know, because we all have lots of emails. You know, I myself have my personal email. I have a work email. I have a business email of my own. I've got my BYU Idaho email. You know, I'm already up to 4, and I know there's more. And so to have multiple emails tied to a single person, well, in Excel, you'd have to, you know, say email 1, email 2, email 3, email 4, and then you're limited to 4, or you have a cajillion columns. Whereas in this sense, we can have one table for people, one table for emails, and potentially have an unlimited amount of emails per person. But then matching them together is the hard part with Excel, right? And so databases are nice because we have all those relationships built to where we can match those up. So that's essentially what we're doing with the join, is we're taking data from 2 Excel spreadsheets and gluing them together with the proper matching. Hopefully the proper matching, depending on how you match them. Okay. Now, like I said, in most cases, because probably one of the biggest things is understanding where to match the data on. You know, what do I put in this on clause? You know, we've kind of gone over a few of these. And like I said, in most cases, it's going to be pretty straightforward where you look for the common denominator. But in other cases, it's not going to be quite so simple, like our common lookup here. So instead, we had to look at, oh, well, we're looking to see what member type they are. And so I like to think about it, like think of each table like a room, and you have to kind of choose which door you want to go through. And in fact, in a lot of cases, when you get into larger databases, you sometimes have to do multiple joins just to get to that one piece of data you want. And so you actually have to kind of like build this whole chain just to get this one column from the table. And we'll have some example of those in the future, but sometimes it's not easy. So basically what I do is you'll notice that I put I always say from, and then I do my inner join. I always try to go in order of the same because like I like to think of it like, okay, I'm starting at member. What's in member? And then so, we can say select everything from member. And member type. Okay, there's their member type. We know that that points to common lookup. So I want to go to common lookup. And so I want to go from member.member type to common lookup ID. So that's what you match on. So that matching is almost like an avenue. It's like your access into that data because it's how we match, right? And so when we choose what we match on, that's effectively defining what data we're going to see. I hope that makes sense, doesn't make it more confusing. And ultimately, I guess here's the big kicker that I always say at the end of this join lab. Practice, and experience. So doing this lab will help ease you into it a little bit. But then also just practice a little bit. If you're sitting there bored, maybe, or if it's troubling, having some troubles, give yourself a little exercise. Say, oh, I want to try to get the last name and the telephone number, and try to go that way. Or I want to see, the movie and what type of DVD, if it's a DVD or a Blu-ray or whatever, you can do all sorts of stuff like that. All right. And that's pretty much what step 8 is actually, is you're going to get the type. And I'm going to kind of, let's see, we have step 9 and 10. So let's take a look at step 9. Write a query, and we're going to join member and common lookup, and we're going to get the credit card type, and we actually just pretty much did this one. Yeah, we just did this one. Yeah, so I'm not going to go over this one because we actually just did that one pretty much. It's a little different, but almost the same thing. And let's take a look at step 10. All right, so we're going to join member and common lookup. And this one's almost the same thing again. Now, there's one important key difference to step 10. And you will, in the count of credit card type columns that are not found in the member table. So essentially, we're going to kind of do this a little bit different. We're going to take and we're going to say, okay, here's all of our credit card types. Is there a credit card that is not being used right now, a type? And we can tell from the results that we're going to, MasterCard is not being used. And in fact, if we were to go back to our results up here, we can see that right here, there is no MasterCard. So essentially what you're going to do is you're going to try to find which credit cards are not being used. And I'm going to kind of let you guys go through a few of those to try to work through it. Because I've given you plenty of examples. You may have to piece some of them together, but I have given you an example of every component situation that there is. Now, I know from my personal experience that part of the problem is trying to piece two steps together. I mean, I know we've all been there where we're like, okay, yeah, here's an example of how to do X, and here's an example of how to do Y, but how do I do X and Y together? And I've actually given you, that's why I tried to do quite a few examples of various situations, why I showed you multiple joins. We did aggregation with a join. So, there should be some examples, but ultimately I cannot stress enough, if you have a problem, feel free to shoot a question out on Teams and we will get it answered. Don't sit and stew for too long, because we can get you taken care of, and it kind of helps me know if there's a lack of understanding. Maybe I completely missed something in the video. And if someone says, oh, I came across this too, and then, a few more, and I'm like, oh, okay, I probably missed something. And then I can either, make a post about it or whatever. But anyways, I don't want to fill you guys up on too much. So I'm not going to try to go over too much because we've pretty much covered all the components of the lab, all the new concepts, ideas. Does anyone have any questions? been a quiet group today. It's got me nervous. I'm hoping that just means that everyone's like, oh, I've already looked at this. It's easy. Anyways. All right. Well, if there's no more questions, thanks you guys for coming, and good luck this week.
Thank you.
Thank you.
Yeah, thank
Thanks.
you.
Thank you.